Okay, so example 1. Now I would not write all of this down, but you have to write down, well, you should write down enough to help you for your homework, for your test, for your quizzes, for your next bell ringer. So a silo is a tall, cylindrically shaped container to hold chopped grain for cattle feed or anything else. I'm guessing most of you know what a silo is. If not, you at least need to write cylinder. Which holds more? And if you wanted to, you could even write a cylinder. So which holds more? Silo 50 feet tall, diameter of 10 feet, or 35 feet tall, diameter of 12 feet. And I'd probably personally write the word, oh, or is right there, never mind. So everything highlighted, I would write down. Okay, so let's think about this. Pictures would not be the worst thing in the world. So here's silo A. How tall is it? 50 feet. The diameter is 10 feet. Thinking about it, the radius then has to be how many feet? 5 feet. So, I'm going to pause for a minute while you make sure you have everything written down up here. You have the picture, and I want you to do the volume formula off of your vocab for, well, I'd probably go straight to the cylinder one. So hopefully you've written down the volume formula. It would be good if you've plugged in some numbers, maybe used a calculator, tried to get an answer. Huge difference between doing math and watching math. We have some choices, but I'm going to go right to volume is equal to pi r squared h. Pi is pi, r is 5. We're not using the 10 directly. The height is 50. I type it in. Pi times 25 times 50. I get 1,250 pi. Going to hit change, and we might as well just round that to a 7. And we are talking about cubic feet. So my first cylinder, 3,927 cubic feet. Now let's do the second cylinder. 35 feet tall, so not quite as big, height-wise, but the diameter is now 12 feet. Okay, do it. I will give you, let's say, 30 seconds. Knock it out. Okay, same formula. pi times 6 squared times 35. Hit change, and approximately 3,958, let's say 0.4 cubic feet. It's actually slightly surprising to see how much height it's given up. The radius matters. This one's larger, not by a whole lot, but it is certainly larger. Price-wise, you would probably want to consider the surface area of both of those. And this might require more specialist equipment because you're going higher. But anyway, answer's done. Here we go. Next example. Some computer paper is 8.5 by 11. In the US, most of it's 8.5 by 11. At some point we should talk about paper that they use in the rest of the world because it's cool with the square root of 2 property, and the scaling's really neat. That might come up in Algebra 2. Anyway, paper's 8.5 by 11 in the US. Suppose a stack of paper has a volume of 748 cubic inches. If the stack is sheared into an oblique parallel piped, which I might have pronounced correctly, with the same height as the original stack, what would the volume be of the new stack? So I have a big stack of paper. I do not draw the stacks leaning particularly well. So if we think of this one, you can kind of make these pop back and forth depending on what you're doing. But if this is the top and bottom, I've got something square right there. And we tilt it over. How much does the volume change? The volume doesn't change. This is the last principle. The answer is to 748 cubic inches, and we're done. If we were going to show work, which I do like showing work, we would write so example 2 is done. Hopefully you wrote down enough. Computer paper 8.5 by 11. Stack of paper, volume of 748. Stack is sheared, that means kind of tilted. Same height. Volume of new stack 748. Cavalier's principle. I probably butchered that. Example 3. We're going to find the volume of this shape. So we've practiced with cylinders, we've talked about the tilt. So the first thing to do is think, what kind of prism is this? We have a base here. We have a base here. We have a height. So we are going to have to break out, and we just know the formula is base times height, where big B for the base means the area, that's the bottom or the top of the prism. Well, that shape's a trapezoid. So I'm going to say, look, the base is 1/2 height, B sub 1 plus B sub 2, where those are the two bases of the trapezoid, which are the sides parallel to each other. So I don't use the 5 or the 7 number anywhere in this problem at all. So you got to be used to looking at that. The height of the trapezoid is not the same as the height of the prism. The height of the prism is 15 inches. That's great. We're going to use that right there in our volume formula. The height of the trapezoid is right here with our right angle. That's 4 inches. So you have to think about where you are in the problem and what height you need. What are my bases? 11 and 16. So my base is 1/2 times 4 times 11 plus 16, 54 square inches. I'm going to take the 54 square inches and multiply by the 15 inches. So volume is equal to base times height. I know the base is 54 square inches, the height's 15 inches, which helps tell us why the answer's in cubic inches, because inches squared times inches. (810 cubic inches). It would be a great idea to read this section. And I want you to do 1 through 22. That's 10.5. You're on page 491 to start. Have a productive day. You have plenty to do.